Okay, in this video, we're going to look at finding the range of a function. So the range, again, is all the possible output values that we get from all the possible input values we're allowed to use. So the problem with range is, for right now, finding the range can be a little bit more challenging with some functions versus others. So in a future video, we're going to look at finding the inverse of a function, which is actually going to make finding the range in this video for the functions we're looking at, it'll make finding the range easier. But for right now, we're just going to look at the graphs of functions to help us in finding the range of each of the examples. So example 2, we're going to state the range of each. So we're using a lot of the same functions from example 1, but we're also going to change up a couple here. So example 2, part A, we have f of x equals negative 2x plus 7. So we said the domain was all real numbers. That doesn't automatically make the range all real numbers, but if we take a look at the graph of our function and zoom out, we notice that all the possible y values that we can think of will be somewhere on this graph. So as far as what kind of numbers we can get in return for f of x equals negative 2x plus 7, we get any number we want in return. So our range is all real numbers. Part B, f of x equals x plus 4 in parentheses squared. Well, in the domain of this, we found to be all real numbers. However, if we look at the graph, our graph doesn't go below the x-axis. So as a matter of fact, our lowest point on our graph has a y value of 0, and then every other point on our graph, like this point has a y coordinate of 1 or 4.182 here, every other y coordinate is either 0 or higher. So for this one, our domain was all real numbers, but our range is going to be y values that are greater than or equal to 0. So again, we'll use the graph to really help us out. Again, don't forget that with range, you're looking at the y coordinate, not the x coordinate. Example C, we have square root of x minus 3. And we saw in the last video that the domain of this was x is greater than or equal to 3. Well, let's see what the range will be. Here's our square root of x minus 3. And if we zoom out, notice that our graph just keeps going up, which means we're going to start at y equals 0, and then all the other points on this graph are going to be higher than that, like 2.324 or 4.336 or 5.158. So for this particular function, our output values are 0 or higher. So the range is y is greater than or equal to 0. Part D, let's negative square root of x minus 3. And as we talked about with transforming functions, this is going to flip our graph over the x-axis. So here's our graph flipped over the x-axis. Now, if we look at our y values, now our y values are 0 or lower, like negative 0.954, negative 1.844. So now if we flip it over the x-axis, our range becomes all values that are 0 or lower, or in other words, our y values have to be less than or equal to 0. Part E, f of x equals the square root of x minus 3 and then plus 6. So we take our square root of x minus 3 and then we shift it up 6 units. So again, transforming the graph of the function. Notice it's still going up, and this time our lowest point, our lowest y value, is a y value of 6. Every other y value, like 7.703 and 9.271, every y value on this graph is either 6 or higher. So for this one, we have y is greater than or equal to 6. Finally, part F, we have f of x equals 3 over 2x plus 5. We said in our last video that x could not equal negative 2.5 because we'd get a 0 in the denominator. Here's the graph of this function. And like I said, sometimes the graph helps, which hopefully it helped for a lot of these problems. This one might not be too easy to see what all of our possible y values are going to be. But I'm going to let you know once again that when we look at inverse functions, we'll find a algebraic way to know we got this answer right. As far as this graph is concerned, you'll get every possible y value you want with one exception, and that one exception is 0. You're never going to get a 0. Reason being is we cannot divide 3 by any number and have it ever come out to equal 0. So 3 divided by any number will never equal 0, which is why this the range of this function is y cannot equal 0. It can equal anything else but 0. So, all right, that about does it for this video. Thank you for watching. I'll see you next time.